Assalamu alaikum everyone. So a few of you wanted examples or actual practical problems related to the real world using whatever we learned. So today we're going to start a new topic, which is a linked list and an introduction to linked lists actually. And as it is actually a new chapter, we can say, but it is also a practical example of memory allocation. Okay, so let's look into it and see what it is. So what is a linked list? A linked list is a collection of data objects, right? So assume that you don't know what objects are, but it's something, okay? Something that contains data. So a linked list is a collection of that something which contains data. And they are not connected by memory, but by links, okay? So as you can see, there's an example here, right? So what's the difference between being connected by memory or being connected by links, right? Okay, so let's see an example, or let's try to understand what it means. So if this is our RAM, and let's say this is a piece of memory which has been allocated to some variable, and this is another piece of memory allocated to another variable, and they have been declared sequentially, right? So now if we say the first memory is 1 and second memory is 2, they are always side by side. That means they're linked to memory space because they're adjacent memory spaces, all right? But if we consider linked list, the memories can be distributed throughout the RAM. For example, in this case, actually it's the same thing but as a stack, okay? Because 1 comes before 2 in the previous example, but now 1 comes after 2. Okay, so in case of linked list, the memories are distributed throughout the RAM. So as you can see here, there are 3 pieces of memories. Let's call this one 1, this one 2, and this one 3. So 1 is pointing to 2 and 2 is pointing to 3. So this is my linked list, and as you can see, they are not adjacent memory locations, or they are not related by memory but by pointers, as 1 is pointing to 2 and 2 is pointing to 3. All right, so if you actually want to create something like that, what do we need? We need a data object as said previously, which contains some data. For example, this one contains 3, right? And another object which contains, for example, 5. And we need some sort of connection between them, which we can, I guess, call a link, right? Which is why this whole thing can be called a linked list. Okay, let's go back to our slide. So each link is a direction or pointer from one object to the next. Without any direction, none of the objects can be found. Okay, so if somehow this direction or this direction is lost, then you cannot find this memory. Okay, because this link is the only thing telling you where that memory is, and as both of them are not adjacent, you cannot find them without the direction. And obviously it is a linear data structure. So what do we mean by linear data structure? It means the data is arranged in a linear fashion. So as you can see here, 5 comes at the very beginning, then after that 7 comes, and after that 2 comes, and after that 1. So this is the linear fashion. If 5 was pointing to more than one data, for example, let's say 5 was also pointing to 2, then it would become a non-linear data structure. So this is the difference between a linear data structure and a non-linear data structure. Okay, so the very beginning of the list is called the head of the list, and the very end of the list is called the tail of the list. So as you can see, all the data items actually point to the next data item, but only the tail will point to the null space, or actually a null pointer. So why do we need this? So that we can understand where the linked list ends. Okay, so the data object can be anything, but for now let's assume that it is a structure. So what do we need in that structure to actually create a proper linked list? We'll see that now. So we'll create a linked list following some steps. Create a structure and call it node. Okay, we'll call each of those data objects node. Each data will contain data, as we already said, and each node will also contain a link to another node. Okay, So we'll be creating the list using nodes. So all of those objects that you've seen, all of those will be nodes and each will be connected to each other. Okay, so we'll create some functions to manipulate the linked list in the following ways. Let's say we want to insert a node in the linked list. Otherwise, why do we use a linked list if not for inserting and deleting nodes and finding or changing a node in the linked list? So we'll see these things, these functions later on. But first we have to create that structure. Okay, so we can create different types of structures according to requirement. The structure can contain a key value, which is the data, and a pointer to the next one. So it can contain multiple types of information or data, or it can also contain pointers to both the next node and the previous node for a linked list that not only connects in the forward direction but also in the backward direction, right? So we can see all three examples are given here. For the first one, the structure can contain a key value and a pointer to the next one. The structure should be something like this. So we call it node again, but now it has only two variables. One is an integer key, which is the data that it will contain, and a structure pointer of node type. So it can actually point to another node, and name of that variable is next. Okay, and the second example is it can contain multiple types of information or data. So as you can see, it contains the same node pointer, but now instead of one information int key, it contains another information name. Okay, so these two variables can keep information and the third variable can point to the next data type. Okay, and for a doubly linked list, it can contain two pointers and only one data variable. Okay, so here these two pointers can also point to the next one and also to the previous one. Okay, so if you want to see double linked list, I can draw it for you. So it will be something like this. So let me erase this first. So previously what we saw is, if this is my linked list, say this is the information 3, this is the information 4, this is the information 5, right? And 5 is pointing to, let's say, null. I'm writing n in short for null. Okay, 4 is pointing to 5, 3 is pointing to 4, right? And we have the head. This is the head. Okay, so now if somehow one link is erased, let's say this one, then we cannot find 4 anymore. Okay, because my direction to 4 is now lost. Okay, now if we have a double linked list, then each of this will point back to the previous node also. Okay, so in this case, if we somehow lose one link, let's say we lose this link, so we should not have any pointer pointing to 5. Okay, but if we have something pointing to 5, then we can point back to 4. Okay, so there are a few differences between a linked list and a double linked list. Okay, but we'll see double linked list later. This is just for you to understand what it is. How it works we'll understand later, so don't rack your head concerning this. Okay, so let's go back to our slide. So at first, let's initialize the node or the first node. Okay, so see here, the code is all written here. We are declaring a node, right? Struct node head, but instead of a data type directly, we are declaring a pointer. What is this pointer? This is actually the head that we were talking about, which points to the very beginning of the linked list, and this will actually be my reference to the linked list. Okay, this reference will always tell me where my linked list is. Okay, and the number of heads. If I can create another head, that means I have another linked list. Okay, so then we'll allocate memory. So as you can see, we have used the function malloc here. So let's see what's written here. This is what? This is the type conversion. Okay, so we are converting whatever data we are or memory we're allocating to a struct node pointer type. Okay, because we're assigning that or giving that memory to this head, and this head is what? A structure node pointer, right? A pointer type, node type, and it's also a pointer. So we are actually converting the memory to a structure node pointer. Okay, and what size? We need just exactly the size of a node, right? So this is what we are giving it, size of then struct node. Okay, so let's see if we have a RAM, what would happen once that line is executed. Okay, so if this is my RAM, whenever we declare a pointer, let's say the pointer is head, we had declared a pointer called head, so a very small memory will be created for the head because it's just a pointer. Okay, it can only contain the address, nothing else. Okay, so now what will happen, the next line was creating another block of memory for the structure. So this is creating the block of memory for the structure, and then using this pointer we are pointing to it, right, when we write equal to. So this is what happens when we create a structure and then assign it allocate memory for the structure and then assign it to a head. Okay, then what are we doing, we are saying that the head next variable, which is actually a variable of the data structure, if you can remember, here you can see. So we are saying that head next equal to null and head key equal to head key. This is actually a macro that we have defined. So the first part is next equal to null. So what are we doing, this is now pointing to null. Okay, and we are storing a value inside it, which is the head key. So let's see what the head key is. The head key is something like this. This is what I've declared the head key as. So why I have given it as minus 33, this is to represent any data that cannot be possible to, that cannot actually exist in the linked list. So this is sort of like a marker. Okay, oh, I just remembered something. Someone told me to change the environment, and I thought that I would change it in front of you so that you can also see how it's changed. So this is actually my editor, right? So if I want to change its environment, do not go to environment, go to editor. Okay, so let's see the settings here, and here you see there's a syntax highlighting. Okay, and I have created a new color theme for myself, but let's change it to default. Okay, so we're back. So let's see, where were we? We created a macro called head key, which contains the value minus 33. So what will happen now? This will now contain the value 33. Oh, very difficult to write using a mouse. Okay, anyways, oh, minus 33. So this will contain information minus 33, and it's pointing to null. Is it clear? So this is how we just created one node from by allocating a memory from my RAM. So I actually created a node out of nowhere. Before writing this line, there was only the memory allocation or memory required to keep an address, nothing more. Okay, so next, what do we do? Before learning to add, we have to learn how to traverse or go through the linked list. And one example is to actually print the entire linked list. Okay, so what do we need to print the list? Of course, we need the head, because the head tells me where the linked list is, and the head is actually my pointer to the linked list itself. So then we have to traverse the linked list. So let's see the code inside it. While the head is not equal to null, what will I do? I will print the head key, printf %d, because the head key is an integer, then head, then this is if you remember, this is an arrow operator using which I can access the key. So head key, and this prints the key. Then what we'll do, we'll move on to the next variable. Okay, next pointer actually. So what will happen, if there was something like this, the head, so this is the head, And if we had another node, then what would happen? At the very beginning, the head will be pointing here, right? Minus 33 or whatever. And then once you print it from this line, once you print it, then we'll be moving on to the next pointer. Head is equal to head next. So now my head pointer will be pointing here. Okay. So if it has another variable, another value, let's say 2, then it will print it, right? So when will it stop? When my head is equal to null, right? Because it continues when my head is not equal to null. So in this case, my head is still not null, right? But let's say this 2 is now pointing to null. So what will happen? When we write head is equal to head next, or for the next iteration, what will happen? It will point to n, right? So now it will be pointing to null. So now my head is null, because now I am not pointing to any specific structure, rather I'm just pointing to a null, right? So now what will happen? It will terminate and print a new line. Is it clear? So this is actually how the printing works. Okay, so I have an example worked out here. I have already inserted some notes. You don't have to understand how the insertion works, but just understand that we have inserted 5, 7, 3 and 1. So then we have called the function print, and the print is just the same as we have already seen in the slides. So let's run it. So as you can see, it prints minus 333, which is the head key, then 5, 7, 3, 1, exactly in the order that I have inserted it. Is it clear? Okay, so I'm going to stop here. Then I'm going to upload my next video, which will contain the rest of the slides. Okay.